Welcome back to the Ephemeris podcast. I'm your host, Aphelion, and thank you for joining me on this episode after what is now a 2 week hiatus. I was very busy with testing this week and was very busy with testing the week prior as well. So I wasn't able to get out a podcast episode for last week, and I had to kind of rush for this one, but nonetheless, we are just, despite that, we are here. And today, we're here to talk about Charles Messier. And for my astrophotography people, he created one of the most famous star catalogs in the world to this day. Lots of very observable objects for amateurs. And yeah, I mean, it's not the most widely used catalog. I think the New General Catalog by William Herschel, which we will talk about in the next episode, might be a little bit more useful in its cataloging just because it has 7,000 objects in the sky. But Messier is definitely one of the more observed one, especially by amateurs, and there's a lot to get into with Messier objects, whereas New General Catalog objects are a little bit less known. So, anyways, without further ado, let's jump into Charles Messier. He was born in 1730 in France, and he first became invested in astronomy when he witnessed the six-tailed comet in 1744 and a solar eclipse in 1748. And I was looking into the six-tailed comet in 1744. It's quite interesting. It was observable with the naked eye for a certain amount of time, and then I think it only had one tail at that point, and then it kind of split into six. There's just a streak of kind of six tails, and hence the name. So yeah, it was a pretty cool one. And the solar eclipses are solar eclipses. Actually, we experienced one yesterday from the time that I'm recording this video. So yeah, interesting stuff. Messier was then tutored by the astronomer of the French Navy, Joseph Nicolas-Delisle, and he's gonna get pretty involved with observation making through him, and also he's gonna get involved with Pierre McCain. I don't know if that's how you pronounce his last name, but those are two people that are going to be important during his life of observation making. But in terms of the observations that he made, the first documented one was a Mercury transit in 1753, which Delisle actually didn't manage to observe as well because the sun was obscured when he traveled up to Russia for it. So, yeah, just cool little side story there. Anyways, so the first thing that Messier did was Mercury transit in 1753, and that's where things kind of kicked off. So in 1758, Messier was working as a draftsman and an observation recorder and operating out of the, I hope I'm saying this right, Cluny Hotel, or he was just, functioning out of some, French Navy observatory. And he was on the hunt for comets. And if you'll remember, there's a comet that was supposed to arrive in 1758, according to some person that we've talked about. And if you know which comet that is, you'll know the one that Messier was looking for. And for those of you who perhaps have not watched the Halley episode, go and watch that. That comet was Halley's comet indeed. So, while Messier was on this endeavor, he came across objects which he confused for comets. But they weren't really comets. And this is not to mention the fact that he was looking in the wrong part of the sky for comets. But, Messier kind of, he sees these objects, and the first one is a fuzz in the Taurus constellation. And it could be mistaken for a comet, but it's not a comet. And if there astrophotographers watching this episode, I will give them a moment to think about what this object could possibly be. I don't think it's going to take that long, so we're just going to move on, and I'm going to tell you that that object turned out to be the Crab Nebula, M1. And honestly, you could have just used logic and said M1. And yeah, so that's the first Messier object that he discovered. Now, all of the Messier objects weren't necessarily discovered by Messier, but they are in his catalog just because of the observations that he did with them. I know M3, or was it M2 or M3, was technically discovered first by an Italian astronomer, for example. But yeah, I suppose it's still in there just because of the notoriety of Messier's observations. And so, yeah, M1 finding this fuzz in the Taurus constellation. I mean, M1, or the Crab Nebula, I should say, is pretty big. It makes a lot of sense that it was the first nebula to be discovered, because you can get some pretty detailed images of the Crab Nebula. And I mean, there's the Andromeda Galaxy, which is M31, and then there's the Orion Nebula, which is M42. But the Crab Nebula is pretty formidable in terms of its size. Also, a good thing to consider, and something I probably should have brought up before I mentioned any of Messier's observation work, is that he was not using a reflecting telescope like Newton. He was still using a refracting telescope, which is likely experiencing chromatic aberration. And you might ask, what is the difference between reflecting and refracting? Not much is given off by the difference in the wording. They sound pretty similar, but what is actually the difference? And so what it comes down to is that refracting telescopes have one objective lens, and it kind of bends the light towards an eyepiece, which is usually kind of at a or like close to the focal point. And reflecting, sorry, I'm having trouble differentiating the words in my pronunciation, but reflecting has two mirrors where there's a primary mirror that's kind of on, it tends to be on the outside, or the reflections tend to happen on the outside of that primary mirror, and it reflects light into a second one, which is smaller, and the purpose of a second mirror would be to direct the light towards an eyepiece, which is usually off to the side of the whole big barrel of the telescope. So if you can imagine what the sort of difference would be there, then you'll get my point when I explain that there's a difference with Messier using refracting telescopes versus a Newtonian telescope. And obviously the main difference is chromatic aberration, as I mentioned, but there are also some aberrations that occur with Newtonian telescopes. I'm not going to get into it, but I think the primary one is probably spherical aberration. So yeah, that's that. I just wanted to give that context in terms of the telescopes. Sort of at the time of Messier, or the ones that Messier was using, and a sort of parallel timeline that's occurring with the development of reflecting telescopes and Newton. So yeah, let's get on with the rest of Messier's observations. With the discovery of one huge nebula using a refracting telescope, Messier wasn't too convinced to start looking for these non-comet objects, but it took him till the third one to start to be like, all right, you know what, I'll start kind of taking notes on some of the stuff that I find that isn't comets. And so he continues to compile this list of objects, and he ends up with 39 galaxies, 4 planetary nebulae, 7 nebulae of other types, and 55 star clusters. And if I'm not doing the math incorrectly, I believe that sums up to about 105. His official catalog was 103, but the observations that he made sums up to about 105. And that's pretty impressive to discover objects which were likely poorly understood at the time with an sort of a instrument that arguably was poorly understood at the time is quite impressive, and that makes the Messier catalog quite relevant till today because there's still a lot that we have to dig into with some of the Messier objects that we know. And yeah, we still peer into them, and they hold a lot of detail that we didn't know at the time that, Messier discovered it, or even Herschel discovered it for that matter. The original Messier catalog, as I mentioned before, was 103, but it has expanded to 110, with astronomers recognizing certain objects as quote unquote official Messier objects. So, yeah, that's information about sort of Messier's discoveries and logistics about the catalog. But let's get into some of the objects, because honestly, if I didn't, then it would be a bit of an injustice to this episode to just say, like, oh, here's what Messier did, and then it's significant because we still look into it today, and then just leave it at that. So, yeah, I'm going to avoid nebulae because, first of all, there's many of them, and second of all, we've talked about nebulae before on the episode in depth, so I don't want to get into that here. But there are some other really, really cool objects. The first one is the small Sagittarius star cloud. It's an interesting name, and rightfully so, because it is not quite a star cluster. There are some other objects in the mix. Sorry. And we're not quite sure what these objects are, but what we do know for certain is that the cloud is a part of an arm in the Milky Way galaxy, and this object that we speak of, the small Sagittarius star cloud, is 600 light years wide and has a depth of about 10,000 to 16,000 light years away. So you can imagine the kinds of things that might be in this star clouds. Lots of gas, lots of dust, lots of, crazy things happening. And yeah, I mean, those are some serious numbers for dimensions, if you ask me. The next object is the Dumbbell Nebula, and this is the first planetary nebula to ever be discovered, and it was by Messier. And what's cool about seeing planetary nebulae is the fact that on top of bright colors, you see knots of bright gas and dust. And it gives these tiny nebulae a little bit of depth. I know we talked about the Crab Nebula being like really big, but planetary nebula can be, relatively small, but when you have these bright colors and these sort of knots of bright gas and dust, it gives the nebulae a bit of depth. And these knots are pretty massive, actually. They're like 3 times the mass of the Earth at a time. So yeah, that is pretty huge. And then let's move on to Messier 32, and this one is a dwarf elliptical galaxy. I know we haven't set aside time to talk about galaxies and their types on this episode, but dwarf elliptical galaxies are one of the more interesting types of galaxies. And what's especially peculiar about Messier 32 is the fact that its structure is quite complex. It falls into this type of elliptical galaxy that is very compact. And of the compact elliptical galaxies, M32 is actually quite an anomaly as well, because half of its stars are within about a 300 light year radius of the sort of central, or the center of the elliptical galaxy, which is really compact. You got to think about how many stars there are going to be in a galaxy and how concentrated it's going to be if you bring them that close. And as with other elliptical galaxies, there's less star formation, less gas, less dust, and all of that stuff. But yeah, we're still sort of debating how such a compact elliptical galaxy even occurred. I think there are theories about sort of tidal fields, but it's a very complex issue. Furthermore, we have got Messier 82, and I tell you what, this one's a doozy. It's a starburst galaxy that can get up to 100 times more luminous than the Milky Way galaxy at the center. And this is the center of the starburst galaxy. And it's believed that the galaxy got into an interaction, or perhaps an altercation, with M81, which is another spiral galaxy. And it happens so that scientists have also discovered the brightest known pulsar in M82. So there's some crazy stuff going on there. And lastly, we've got Messier 84, which is an elliptical galaxy, not quite like M32, but it has a supermassive black hole somewhere in there, and it's ejecting a ton of matter in jets. I'm going to assume that they're bipolar, but they could not be. They could just be jets of matter. And it has a couple of star-forming regions, contrary to what is common with elliptical galaxies. And M84 has 2 supernova. And supernova, I mean, you can find a couple in some of the other galaxies in the Messier catalog, but yeah, it's also present in M84. So those are some interesting Messier objects, and that is pretty much the work of Charles Messier and the man himself. So yeah, if you guys enjoyed listening to this episode, I would sincerely appreciate a follow on Spotify and a subscribe on YouTube, depending on where you are listening. And yeah, I will hope to see you next week for the next episode, which is going to be on William Herschel. So until then, I'll see you later. Peace.